Okay, so welcome back to this next video in which we are discussing drug addiction. Okay, right, so we're in the process of discussing the brain's natural reward system. Okay, and so far what we've discussed is the relevant neuroanatomy for discussing the brain's natural reward system. So we've discussed the ventral tegmental area here, which is this special section of the midbrain containing neurons which produce and use the neurotransmitter dopamine. Okay, now the neurons in this section of the ventral tegmental area are going to send their axons to many different brain areas, and two of the most important areas that they're going to send their axons to are the cortex and also the nucleus accumbens. Okay, now the pathway to the cortex we've discussed is called the mesocortical pathway. Okay, and it involves dopaminergic axons being sent into the medial forebrain bundle, and you have two medial forebrain bundles, a left medial forebrain bundle and a right medial forebrain bundle, and then what will happen is these will go forward, and the left medial forebrain bundle will supply the cortex of the left cerebral hemisphere, and the right medial forebrain bundle will supply the cortex of the right cerebral hemisphere. Okay, so these dopaminergic axons will be synapsing either through en-passant synapses or through neural synapses or through varicosities. They'll be releasing dopamine onto the neurons of the cortex. Okay, right, and remember the main sort of receptor for dopamine that you have within the cortex is D1 receptors. Okay, then we also have the mesolimbic pathway, which is this projection from the ventral tegmental area to the nucleus accumbens. Okay, the left nucleus accumbens and the right nucleus accumbens. Okay, and again the dopaminergic axons go into the medial forebrain bundle, they then leave the medial forebrain bundle and go to the nucleus accumbens. Okay, now the portions of this neuroanatomy that are going to be very important in the brain's natural reward system are the dopaminergic projection to the nucleus accumbens and also the dopaminergic projection to this particular portion of the cerebral cortex known as the medial prefrontal cortex. Okay, these are the two portions that we are going to need. Okay, so now I think we are ready to discuss the brain's natural reward mechanisms then. Okay, so this is known as the reward system, okay, and I'm going to present what we understand of the reward system at the present. Okay, so the first thing that I want to stress is that this is at present we believe this is a teaching system, okay. Now, this needs to be contrasted to what we used to believe this was. We used to believe that this was the hedonic signal, okay, and we don't believe that anymore, and I will explain exactly what we used to mean by the hedonic signal, and I will contrast that to what we now believe dopamine is involved in, which is producing a teaching signal. Okay, right, so let me explain this then. Okay, so the idea is then that you have a basal level of dopamine release from the ventral tegmental area into the medial prefrontal cortex and the nucleus accumbens. Okay, so the dopaminergic neurons in the ventral tegmental area, they are active from time to time, and they'll be releasing dopamine into the medial prefrontal cortex and the nucleus accumbens. That's some basal rate. Okay, the idea is that you can activate the ventral tegmental area, okay, and then you will get increased amount of dopamine being released into the nucleus accumbens, and also an increased amount of dopamine being released into the medial prefrontal cortex. Okay, the idea is that an increase in dopamine in these two areas an increase in dopaminergic transmission in these two areas is going to give a teaching signal. Okay, now what's it going to teach about? Well, let me give you a scenario. Okay, so let's say that you are exposed to some stimulus that you have never been exposed to before, ever. Okay, so for instance, let's say you are exposed to some stimulus, and we'll have an example. Let's say you have never eaten chocolate before, okay, and you have just been exposed to this new stimulus. Okay, so this is what we're going to start off with. We're going to eat a bar of chocolate, and we've never eaten a bar of chocolate before in our life. Okay, now, the stimulus has two features. Firstly, it is unexpected. We don't know what to expect. We've never come across this stimulus before in our life. Okay, and secondly, it is very much so pro-survival. Okay, so it's pro-survival stimulus. Okay, now I know in the Western world we view chocolate as being bad for you. Okay, in reality it is fantastic for you. If you have not eaten in weeks and weeks and weeks, chocolate is a fantastic energy source. Okay, it would be fantastic to come across a bar of chocolate. Okay, it's just that in the Western world we are completely overnourished, and that's now actually causing problems. It's causing diabetes and obesity and metabolic syndrome. Okay, so now we view this as actually unhealthy, but in fact it's too healthy is the reality. Okay, it's too good for you, and we're having too much of a good thing, basically. Okay, so this stimulus then is unexpected and it's extremely pro-survival. Okay, so what's now going to happen is the brain is going to process all of the information that it's getting about this chocolate. So it's getting the fantastic taste of the chocolate, okay, from the gustatory system. It's also getting information from the intestine about the nutrient contents of the chocolate, and information potentially from the liver as well about the nutrient contents of the chocolate. Okay, so it's getting all sorts of signals coming to it. Okay, and what's going to happen is, I'm going to put a box here. What will happen is the brain will process all of this information. Brain processes information, and it comes to this same conclusion here. Okay, that this is very pro-survival. Okay, so the brain needs to process the information and decide that this new stimulus that it had no idea what to expect from is actually extremely pro-survival. And I'm afraid this is very black boxy, okay, but I really can't give you any more than this. Okay, the brain decides that the chocolate is good and that it didn't expect it to be good. Okay, right. Now, when this happens, when the brain realizes that this stuff is fantastically good and that it previously had no knowledge or expectation of this stuff, it's going to say, we need to adapt, we need to teach ourselves, we need to do something about this. This stuff is fantastic. We had no knowledge of this. We need to now change our brain. We need to remodel the brain so that we now do know something about this. And we know that it's fantastic, so we should be trying to get more of this stuff. Okay, so we now need to remodel the brain so that we are going to seek this stuff more, basically. Okay, and basically, the idea is that then what will happen is you will activate the ventral tegmental area, and this is very important. In the normal reward system, you get all sorts of processing by the brain. It then decides that this stimulus is extremely pro-survival, and it's then going to activate the ventral tegmental area. We're going to see that the addictive drugs do this in a very different way. They short-circuit this. They cut out all of this first bit here. They cut out the processing by the brain that says this stimulus is pro-survival, and they just activate the ventral tegmental area directly. And that's the basis for their incredible addictive properties. Okay, right. So the brain is then going to activate the ventral tegmental area, okay, in the midbrain, and now the ventral tegmental area is going to release more dopamine. So dopamine release is going to go up, specifically in the nucleus accumbens, which I'll abbreviate as NAC, like so, and also the medial prefrontal cortex. Okay, so I'll highlight this one in yellow. Okay, so dopamine's going up in these two places. Okay, and now the dopamine is viewed as the ultimate teaching signal. Okay, dopamine going up in the nucleus accumbens and the medial prefrontal cortex is then believed to act as the signal that says, right, we need to remodel now, we need to change the brain so that firstly, we crave and want this stimulus. We crave and want the chocolate. We start seeking the chocolate. And also, so that we can remember how we got the chocolate. Okay, so, what we're now going to get is remodeling. Okay, so firstly, we're going to start craving the chocolate. So I'll firstly just box my remodeling in orange here, and then I'll tell you what the remodeling is going to achieve. Okay, so it's going to achieve two main things. Okay, firstly, it's going to establish cravings and wantings. So previously you had no knowledge of chocolate at all, so you didn't want it or crave it at all. Okay, but now you know about chocolate, you're going to crave and want it. So craving and wanting is one of the things that we're going to produce. Okay, so we're going to alter motivation, basically. We're going to start seeking chocolate. Okay, this pro-survival stimulus. Okay, in addition, you need to alter memory. Okay, because you need to remember, how did you get this chocolate? Okay, and we need to start associating the signals that tell us that potentially we could go and get some chocolate, and we then need to initiate the behavior of going and getting the chocolate in response to those signals. Okay, so we need to be forming associations, basically. Okay, so let me give you the example of this. So basically, you're going to be associating the cues which tell you that you can get the stimulus. Okay, so in the case of chocolate, that will be the shop. Okay, the shop window, let's say, full of Easter eggs, maybe. Okay, and then you're then going to associate those cues with the actual initiation of the seeking behavior, okay, which is the behavior of actually going into the shop and buying the chocolate. Okay, so you now want the cues, which previously meant nothing, to actually initiate the behavior of going and getting that stimulus. Okay, so the association of the cues with the behavior, it needs to be formed. Okay, and that's part of memory, basically. Okay, so you need to associate these two things together. Okay, and that's also going to be achieved by the dopamine. Okay, so the rise in dopamine in the medial prefrontal cortex and the nucleus accumbens achieves these two things. Okay, and overall what this results in is you getting more of the stimulus, basically. You carrying out the behavior that results in you getting the stimulus more often. Okay, so you're going to now get the stimulus more often, and you can see that that's a very good system to have. Okay, this is going to help you survive, because it's going to help you motivate yourself to get stimuli which are actually beneficial for your survival. Okay, so this is a fantastic system to have, basically. Okay, but it's going to be abused by the drugs of addiction. Okay, now, before I go any further, this is what we currently understand the reward system to be. Okay, let me talk about what it used to be viewed as being. Okay, and I want to make sure that you understand that it is no longer generally viewed as being the hedonic signal. Okay, so firstly, what does this word hedonic mean? Okay, hedonic means pleasure, happiness and pleasure. So the way we used to think of dopamine was that it was the happy hormone, and if you go on certain websites you will still hear it described as the happy neurotransmitter. We don't think it is anymore. We think it has this subtler, more sinister function of remodeling the brain so that the behavior that gave rise to this good pro-survival stimulus is reinforced, okay, so that you do it more often. Okay, but what we used to believe was that rises in dopamine in the nucleus accumbens and the medial prefrontal cortex, particularly the nucleus accumbens, was responsible for that pleasure that you get when you eat something lovely like chocolate. Okay, we don't think it is anymore. We think that the hedonic signal is instead due to endorphins and things like that, so beta endorphin being an obvious example. Okay, so we don't think it's the hedonic signal anymore, and in fact, if you continue eating chocolate, so let me just tell you more about this, let me exaggerate this point of view. Okay, if you continue eating chocolate, okay, and you get used to chocolate, okay, eventually you will expect chocolate to be very pro-survival, to be a good thing. Okay, so what will happen is you will eat chocolate now, your brain will process it, it will say, okay, this is very pro-survival, good, but now we expected that, we know that this stuff is Good, okay? Now we don't need to be taught anymore. Okay, and therefore it will not activate the ventral tegmental area anymore. Okay, so you will not get the rise in dopamine in the nucleus accumbens and the medial prefrontal cortex anymore, and that is what is seen. Okay, we see that dopamine doesn't just go up in response to good things, okay? It goes up in response to good things that are unexpected, good things that you are seeing or experiencing for the first time, okay? Not just good things, okay? And that's the basis of us thinking that it's a teaching signal. It's the signal that causes remodeling of the brain so that the behavior that gave rise to the stimulus can be reinforced, which just means that you're going to do it more often, basically. Okay, once you have learnt that this stuff is fantastic and you have got the behaviours needed to acquire it, and you've got the cravings and the wantings, okay, once that's all done, you don't need the dopamine signal anymore, and you don't get the dopamine signal anymore, and that's how these addictive drugs are going to differ from normal pro-survival stimuli. Okay, normal pro-survival stimuli, once you've learned about them, once you've remodeled the brain sufficiently so that you now seek these pro-survival stimuli adequately, you stop teaching the brain to do it further, okay? So the dopamine signal stops. The addictive drugs are never, ever going to stop delivering a dopamine signal. So they continuously trigger the brain to remodel itself so that the behavior of seeking these drugs is reinforced. Okay, that's what's terrifying about them. Okay, so let's now move on then to the addictive drugs. Okay, so absolutely all the drugs of addiction, okay, all of them act on the ventral tegmental area in some way, okay, and they cause an increase in dopaminergic transmission in the nucleus accumbens or the medial prefrontal cortex, okay. So addictive drugs are going to raise dopaminergic transmission in the nucleus accumbens and the medial prefrontal cortex. That goes for absolutely all of them. Okay, now they do not do this in the same way that good pro-survival stimuli do it. Sorry, I'm saying stimuli do it. Okay. Instead, they do it by acting directly on these neurons in some way, or by acting on neurons that act on these neurons, okay, and we'll see many examples of this. Okay, remember, normal pro-survival unexpected stimuli, those have to be processed by a huge black box that I've got here, which is the brain. Okay, there's a huge amount of processing that has to occur, which is beyond our understanding. Okay, and then the brain decides this is a fantastic stimulus that we've just experienced. Okay, we didn't expect it. Okay, we need teaching, so let's activate the ventral tegmental area. In contrast, the drugs of addiction are going to just activate the ventral tegmental area without going through any of this processing, and they never stop doing it. They will continue doing this every time you administer them. So you just continually remodel the brain so that the behavior of taking the drugs becomes reinforced, basically, so that you get stronger and stronger cravings and wantings for the drug, and so that you get more and more of these associations formed. Okay, and these associations become so strong in the case of drug addiction that it almost usurps or displaces voluntary control of behavior. Okay, so it almost gets to the point where you see a drug-associated cue, so maybe a place that you associate with the drug of addiction. Okay, so I'll just put some drug-associated cues here. So there's a good word with regards to the drug-associated cues, which is paraphernalia. Okay, paraphernalia. Okay, let me just check that I haven't spelt that wrong. I have spelt it wrong. Paraphernalia, it should have a P there rather than a T. Paraphernalia. Okay, so paraphernalia means the equipment that is used to deliver the drug, so maybe syringes and things like that. So that would be a cue associated with the drug. Also, there might be certain places where you take the addictive drug, and potentially certain people with whom you take the addictive drug. All of these are drug-associated cues, and basically what they're going to do is they're going to initiate the behavior of taking the drug. They're going to initiate the drug-seeking behavior, and these associations that can be forged, okay, by the continuous remodeling of the brain that the dopamine produces can be so strong that they become almost involuntary, i.e. you see the drug-associated cue and then you initiate the behavior of trying to take the drug. Okay, so they can become so strong that it can almost displace voluntary control, okay, which is truly scary. Okay, so I hope now that you understand the basic concept then of how addictive drugs work, that they are hijacking this system, and unlike the way this system usually works, where it stops working after a while, okay? So once you have got enough cravings and wantings, and once you've got enough associations, then what will happen is the brain will stop activating the production of more of these. Instead, the addictive drugs just continue activating this system. They continue activating the remodeling all the time, and eventually the drug-seeking behavior can just dominate the lives of these people, okay, who take these drugs, and to the cost of everything else, basically. So everything else becomes unimportant. All that becomes important is finding the drug and getting more of the drug, okay, and that is consistent with this complete overactivation of this remodeling of the brain that results because of dopamine, basically. Okay, so you're going to continue creating cravings and wantings, and you're going to continue forging these associations between drug-associated cues and drug behavior. And that's what creates then the addiction, which, remember, we originally defined as continuing to take the drug even though it had negative life consequences. Okay, right, so that then now is the basics of drug addiction, okay, in the context of the neural reward system. What we're going to do is have a break here, okay, and then in the next video what we will do is we will look at examples of addictive drugs and see how they're going to hijack this system, okay, to produce an elevated level of dopaminergic transmission in the nucleus accumbens and medial prefrontal cortex.